and forget. So again, we're starting on number 4 on 5.1. So we did like the first page in 3/4, I think. These problems in number 4 that we're starting with are just like number 3, but the answers here are in radians. And remember that my range here is between 0 to 2 pi, but I've got parentheses at 2 pi, so I'm not including 2 pi. I'm going all the way up to 2 pi, but I do not get to include it. The reason is 0 and 2 pi kind of give the same answers. And so we're going all the way up to it. That would just start repeating answers and we don't need to do that. So if you think 2 pi, you're not wrong. It's just not in our range. So we're not going to use that. All right. So we've got 4 problems like this where we're going to solve it and we're going to get x by itself. So let's start here. Just like we were doing above with my degrees, I'm going to get everything to one side. So I'm going to minus tan x on both sides. I've got tan x sine squared x minus tan x equals 0. And kind of the fun part about this chapter is it's all algebra. We're just using trig ratio. So I'm just using sine and tangent and stuff in place of like x's and y's or 2's and 3's. But it's very similar to what we've done in the past. I'm going to start by factoring out a tangent. So I've got a tangent here and a tangent there. So we're going to take tan out and I get sine squared x minus 1 left on the inside. Tan divided by tan is just 1. That's kind of a common thing we're going to keep going back to. And then now I get to set each of the factors equal to 0. So I'm going to set tan x equal to 0. And I'm going to set sine squared x minus 1 equals 0. I just spent a lot of time with my geometry kids factoring and we practice, setting each factor equal to 0. This is the same thing, just now we're in pre-cal and now we're going to do tan of x equals 0 and find x there. That means that we're going to figure out what angle is my tangent or my y over x equal to 0. Well, we know that y over x, in order for that to equal 0, we have to have a 0 on top and then like something else on the bottom. So my question now in my head, I'm asking myself, okay, what angle has a y of 0? That's in between 0 and 2 pi. The ones with y's of 0 are my 0 degrees, 0 degrees or 0 radians, and then over here at 180 or pi. Now you might want to use 2 pi here, but I just told you a minute ago, we don't get to include 2 pi. Recognize that that's true, but that's not part of our answer set. So my answers here are going to be 0 radians and then pi radians because they go at these 2 points. Anybody have questions on that? Okay. The next part, I got to do my sine squared minus 1 equals 0. So let's get x sine x by itself. Let's add 1 to both sides. I get sine squared x equals 1. And then I have to get rid of the square by square rooting. Come on, pen. There we go. Which gives me sine of x equals, and this time it's plus or minus 1. When you do square root of 1, it could be positive 1 squared got you 1, or it could be negative 1 squared got you 1. So we have to treat it as plus and minus. Remember that sine is my y value. So now we're asking ourselves, where is my y? Where is my y going to be positive or negative 1? Well, you look at your unit circle. You might remember, now that we've done unit circle for a long enough time, your y's are 1 at like the points on the y-axis. So I've got a point at 0, 1, and I've got a point at 0, negative 1, and those are at 90 and at 270. Well, I don't want my answers in terms of degrees. I want it in terms of radians. So I'm going to write my answer over here, and the answer in terms of radians for 90 is pi over 2, and my answer in terms of radians for 270 is 3 pi over 2. So those are my answers for this problem. Any questions so far? Okay, let's go up, keep going. If you guys are good, let's keep rolling. We got 3 more like this. I'm gonna do 1 more with you, and then I'm gonna have you try letter C, and then we'll do the last one together again. This one's pretty simple. I've got tan squared x equals 3. There's no other trig function, so we don't need to bring everything to one side and then set that equal to 0. This is already just like one variable. Tan squared x is like just one thing, nothing, no other trig functions. This is good to go. So let's start by getting rid of that square by doing the square root of both sides. So that gives me tan of x equals plus or minus root 3. Okay, so again, we did the square root, we got to do plus or minus. Now my kind of first thought is, okay, I need my tangent, which is my y over x, to equal root 3. We've been doing this long enough, and we did a lot of those unit circle quizzes at the beginning of this chapter, that like you should kind of have an idea of how to get root 3 for my tangent. If I have a tangent of y over x, something over something else, to get just root 3 by itself, I need the root 3 over 2 to be on top, which would make my 1/2 go on bottom. And if you were to simplify that, root 3 over 2 times reciprocal 2 over 1, that gets just root 3 by itself. So I'm essentially on my unit circle looking for the point 1/2 comma root 3 over 2. One half comma root 3 over 2. So now go to your unit circle, find where that is. Again, it can be positive or negative, so I'm going to locate every single point where this is at. I know, and again, I've done this long enough that like I know the point 1/2 root 3 over 2 is a 60-degree angle. And if you didn't know that, you should find pretty quickly that it's at my 60-degree. And we're going to list all of those radians that are at my 60-degree reference angles. So that's pi over 3. Again, I'm still in my radians. That's why my answers are in radians. That's 2 pi over 3. That's 4 pi over 3. And it's 5 pi over 3. Ooh, that was way too big. Again, I'm listing all of those because it says plus or minus. And those are all my answers. Anybody have any questions so far? Okay, I want you to try letter C. So take a minute, try letter C. I'm going to join you in a second. So if you have no idea, at least see if you can start it. Move everything to one side, factor out what you can do, set each factor equal to 0, and then I'll join you momentarily. If you don't know what you're doing, I'm coming to help now. If you are good, just keep rolling. Move everything to one side, and I'm going to factor out any common factors. I've got sine x tan squared x minus sine x equals 0. And I have a sign in both of these, so I'm going to factor that out. Sine x, and I get tan squared x minus 1 equals 0. I got to set each of these equal to 0. Sine x equals 0, and tan squared x minus 1 equals 0. And I've got sine x equals 0. Okay, so I'm thinking to myself, where is my sine or where's my y? 0. And that's at 0 and pi. And then now I gotta do the same thing for my tangent. Tangent squared minus 1. Okay, add 1 to both sides. Square root both sides. And that gives me tan x equals plus or minus 1. Okay, so now I've got to be like, okay, where's my tangent or my y over x equal 1? Now, a lot of us want to think that that's just your x or your y, so you're like trying to go to one of the coordinate angles. However, in order for tangent, which is y divided by x to equal 1, I need the same thing on top that I have on bottom. And again, I've done this long enough, but you've also done this long enough that you should remember that we need the same thing on top and bottom. And the only point that's the same for your x and your y is 45, root 2 over 2, root 2 over 2. So 45 and all of its reference angles. That'd be root 2 over 2 times 2 over root 2, which cancel, and I get 1. So we're looking at our 45-degree angles. That means that x is at, and again, I'm in radians, so I'm at pi over 4, I'm at 3 pi over 4, I'm at 5 pi over 4, and I'm at 7 pi over 4. You could write all these answers together, or you can just list them by themselves. That's totally fine either way. All right, a little bit of a longer one. Anybody have questions on letter C? Okay. The last one I do want to do together. So if you started on your own, awesome. However, I think you might go look at it and then be like, oh, I don't really know where to start. 4 cosine squared x minus 4 cos x plus 1. I want to make it a little simpler. Let's replace cos x with x. So what if instead of writing cos x, I'm just going to write a normal x, and then I'll go back and replace it with cos x. Okay, that means that instead of being 4 cos squared x, it would be 4x squared. Instead of 4 or minus 4 cos x, it would be minus 4x, and then it would be plus 1 equals 0. So by taking out the cosine and just putting one variable in, this looks like stuff you did back in Algebra 1 and in Algebra 2. This is just factoring. We've done this before. Now, it's kind of a funny factoring, though. Normally, I put like numbers here. I was like, okay, something x and something x. I would normally try 4 and 1, and I can try that to begin with. The last box is going to be filled with minus 1. So it has to be minus 1 because it multiplies to be a positive number and it adds to be a negative number. And the only numbers that multiply by 1 are 1 and 1. Now, when I start to do my outside inside, I get negative x and then I get minus 4x. That's negative 5x, not negative 4x. So I can't do 4 and 1. Let's actually split it to be 2 and 2 and see what happens. Okay, 2 and 2. That gives me minus 2x and then 2 times negative 1. Oh, negative 2x. Oh, perfect. That's negative 4. So this 4x squared minus 4x plus 1 factors down to be 2x minus 1 times 2x minus 1, or I can rewrite that as 2x minus 1 squared. Now, if you got all tripped out by my factoring, let me know because we can do that sometime outside of class, but factoring should have been a skill that you already know. Once I factored it down, though, I'm going to go back and take that x out and put in my cosine x. So I just replaced it so that factoring looked easier, but I can't solve it until I put cosine back in. So now I'm going to say not 2x minus 1, I'm going to say 2 cos x minus 1 squared equals 0. Zoom it back out in case anyone's confused still. And now I'm going to solve this just like I solved all the other ones. It's already, my factor is already set equal to 0. I just got to get cos x by itself. Any questions before I start isolating for cos x? Okay. To get rid of the square, I'm going to square root both sides. Square root, square root. Square root of 0 stays 0. So that's cool. I get 2 cos x minus 1 equals 0. Add your 1 to both sides. I get 2 cos x equals 1. And then divide by 2, I get cos x equals 1/2. Again, this is just algebra. So if you struggle, and I say again, maybe it was just the other class I talked to about this, but a lot of this chapter is algebra. I just put in trig functions for it. So if you struggle with it, it might just be because your algebra is a little shaky. So double check kind of like, okay, did I solve for x? Did I solve for my variable? I added 1, I divide by 2. Check those basic things first before you ask a question. A lot of times your question is just algebra. Now, everything was algebra until the end, and this last step is a trig step. This is our kind of our new step. Cosine of x equals 1/2. Well, we know cosine is your x value. So I'm looking for where x is equal to 1/2. Not negative 1/2, positive 1/2. So I go to my unit circle. I know cosine is positive in quadrants. Oh, sorry. I know cosine is positive in 1 and 4 because all students take calculus. All in calculus is where my cosine is positive. In cosine, my x is 1/2 at my 60-degree angle. So again, all my answers are in radians. So I'm going to do pi over 3. And then the 60-degree angle in this fourth quadrant is 5 pi over 3. I messed that up last class, so just be super intentional about which your quadrant you're in. I did 1 and 2 for whatever reason. So make sure that you're reading your unit circle or you remember which quadrants it's true in. It's really easy to mess up. I literally did last period, so just be careful. Okay. That's it for those types of problems. Does anyone have questions on those first 4 problems we just did? Okay. Next, the last 2 problems for this section are calculator problems. So I'm going to pull my calculator out. Get yours out if you have one. Five and 6 say use the calculator to find all solutions of cosine or of something something. Give the answers in both degrees and radians. So number 5 says we want to find all of the values, all of my answers for cosine x equals 0.37. Remember when we're doing this, if I'm finding x, if my answer is going to be x, and this is actually a helpful reminder for your test tomorrow, anytime I want to do cosine x and I don't know my angle, we have to do second cosine. So I have to do x equals cosine to the negative first 0.37. Now, some of these are unit circle stuff that we've done before. For tomorrow, all you have to do is just plug it in and call it a day. But for this one, we're going to use all of the solutions for degrees and radians. So let's figure out what the calculator just spits out for us for degrees and radians, and then we're going to have to add on to it. So I'm going to go and make sure I'm in degrees first. You could be in radians because we're going to do both, but I'm going to do degrees first. I'm going to do second cos 0.37, and I get 68.28. Just go 2 places after the decimal. That's okay. 68.28. I'm also going to do it in radians before I tell you more of what's up. So I'm going to go to radians, do the exact same problem, second cos 0.37. And this time I get 1.19. You can call it radians if that makes you happy. Okay. When it says find all the solutions, I didn't do this in a great place on my notes. Hopefully your notes look better than me. Remember that we've got our circle, and I know it's not a unit circle because 68.28 is not a perfect number on our unit circle, but that would be somewhere in here. It would be somewhere like in this first quadrant. 68 point something, something, something. Now, we could have it in positive 68, or if it's cosine, we could also have a positive cosine ratio in not just the first quadrant, but also the fourth quadrant. So we could also have it down here. So to represent it in the fourth quadrant, we could also do negative 68 point blah, blah, blah. So to represent that, we're going to write plus or minus 68.28. Now, in addition to that, we don't just have to go, plus 68 or minus 68. We can keep going around and around the circle. We could go around forever the positive direction, and we could also go around forever the negative direction. So in order to represent that, we say plus or minus 68.28 plus 360 n. That n is any whole number amount of times around my unit circle. So I could go 5 times around the unit circle and the same answer would be 68.28 plus whatever 3 or 5 times around the unit circle would be. We're gonna do the same thing with radians, but instead of adding 360, I'm gonna add 2 pi because that's the same thing as 360. Again, I'm still gonna have plus or minus. I'm gonna say plus or minus 1.19 plus, and this time it's gonna be 2 pi n. And those pink answers are my answers. N is just any whole number circles around the unit circle. Okay. It's not hard, but you kind of have to remember that like little specific skill about it. Because it's not like we can just go one time around. We have to go all and all and all as many times as we want. We're gonna do the exact same thing with tangent of x equals 5. So let's go do that. Let's do tangent of x equals 5 in our calculator for our answers. So we'll find what the basic degree in radian is, and then we'll work from there. So I'm gonna do x equals inverse tangent or second tan or tan to the negative first of 5. I'm gonna do it in degrees. So I got 78.69 degrees. And then I'm also going to do it in radians. And again, I like to just kind of set myself up and then I'll think through it. Oh, not negative 5, positive 5. Radians, it's 1.37. Anybody question with the calculator part? It should be the easy part. Okay. Now we're doing tangent. Last time we did cosine, this time we're doing tangent, and it's like 78 point something something degrees. Okay, so that's where it would normally be. Now we are not going to say plus or minus this time, because if we said minus 78, it would be somewhere in this quadrant. Its tangent is positive 5. So remember, all students take calculus. Tangent is only positive in 1 and 3. So we actually want it to be the 1 and the 3 angle that we see. Now let's think about how we can replicate that. I'm going to just do normal 78.69 plus 360 and goes around and around and around and around and around and around forever. Now I'm not going to do minus plus or minus 78.9, because if I said plus or minus, then that would be in the fourth quadrant, and I don't want that. I only want it in the first and the third. Now to represent it in the third quadrant, we're going to say it's 180 plus 78. Again, I'm adjusting it because I want it to be in the quadrant I want it to be in. I want it in quadrant 1 or quadrant 2. So I'm going to say 180 plus or minus n. And again, I can go here and around and around and around and around forever and ever. So I'm going to say not just 78.69 plus 360n, but I'm also going to say 78.69 plus 180n to represent it only going halfway around and a little bit more. Same idea with the radians, but instead of doing just plus or minus for 2 pi, I'm going to do positive 1.37 plus 2 pi n, and then positive 1.37 plus pi n. Those represent each other. 360 and 2 pi are the same, 180 and pi are the same. So those answers in pink are again my answers. So we had to do just a little thinking to figure out which quadrant it was. When it's cosine, that's when it's plus or minus, and when it's tangent, we have to do it in 180. And so we have to kind of use our brains to think about what makes the most sense. Okay, anybody questions or thoughts so far? Okay, that's the end of 5-1. Remember, I said that's going to be due on Thursday. So test tomorrow, couple more days to work on your homework. We're going to get into 5-2, and we were able to do all 6 of these in my other period class. So I'd like to get through all of those today. I'm doing a lot of heavy lifting today because next time we have like notes in class, I want to do some of these where you guys practice them because I think they're not too difficult, but you have to work through them yourselves. You have to struggle with it. It's a little bit more like a proof or algebra than it is other things. So, okay, we're officially getting into 5-2, and I want to do these 6 problems before we go. And I want you to get your unit circle out. So I'm just going to jump over for 1 second. Oh, yep, this is right. Unit circle. Remember last time in class when we started 5-1, I told you to write these identities on the back of your unit circle. We have the reciprocal identities and we have the Pythagorean identities. I want this up, or I want it visible for you to see because I can't show them both at the same time. We are going to use these. We're going to use the reciprocal functions and we're going to use the Pythagorean identities. These are things that you will need to know. You will have to have these memorized eventually, but until then, have them up so you can start recognizing things so you know what to look for. Those are kind of our tools that will help us adjust from one thing to another. Okay, any questions? All right, let's do it. So I'm doing number 1, and all of these say verify. That means like prove that they are true. I have a full equation now, so it's not just like one thing that I say like simplify it till it's the most simple. I'm telling you where to go. I'm saying this is your end destination. If you do not get to sine x, you are not correct. You are not finished. So I actually like 5.2 better because it tells you how far you're going, or it tells you when you're done, or it kind of helps tell you like where we want to go with this. These will always be true, so you'll never get halfway through and be like, oh, I can't solve this. Like they will always be true. So I'm going to take the most complicated side, and in this case, it's the left-hand side. I'm going to get the most complicated side to equal the simplest side. And when I see that they're the same, I'm going to say, check mark, good, I'm done. So if I start on this first one, I've got sine squared x plus cosine squared x over cosecant x. A good first step might be thinking, okay, I've got cosecant x, let's make it in terms of sine. An even better first step would be to recognize that sine squared x plus cosine squared x is one of your Pythagorean identities. Sine squared x plus cosine squared x, if you go back to our unit circle or you have yours up, that's the same thing as 1. Sine squared plus cosine squared is 1, so I replace that entire numerator with 1, and I've got 1 over cosecant x. Now I look back at my identity sheet and say, okay, do I know anything about 1 over cosecant x, or do I know how cosecant relates to something else? Get it in terms of sine and cosine if at all possible. And 1 over cosecant x, this is one of your just reciprocal functions. It is equal to sine x. Oh shoot, we did it. Sine x equals sine x. That's what we wanted it to equal. I did it. I'm good. The end. So again, we have to look for our Pythagorean identities, and then we have to use our reciprocals to either, or to get it in terms of sine and cosine, and then we simplify from there. Any questions on the first one? All right, let's keep going. Second one, I've got tan x over secant x equals sine x. Again, go for the most complicated one, and tan x over secant x is more complicated than just sine x. So we're going to start with the left-hand side. I would look for any trig or some Pythagorean identities, but there's nothing squared here, so there's no Pythagorean identities for me to do. However, I can do like my second most common first step, which is to simplify, get this in terms of sine and cosine. So I've got tan x. I know I told you that tan x is the same thing as 1 over cotangent. However, that's like not a super useful piece of information. What's more useful is that tangent is the same thing as sine of x over cosine of x. Tangent is sine x over cosine x. And then secant is the same thing as 1 over cosine x. These are ones that like you should kind of know off the top of your head. If you don't know them, we got to start knowing them, especially the reciprocal ones. You should be like, oh yeah, I know secant's 1 over cosine. Oh yeah, I know tan is sine over cosine. Now I've got to simplify it to be in terms of sine and cosine, but it's still an ugly fraction over a fraction. So let's simplify that. That becomes sine x over cos x times the reciprocal of the denominator, which is going to be cos x over 1. Sine x over cos x times cos x over 1. Oh, I've got cos on both top and bottom. They cancel out. And that gives me just sine of x. Oh, and that's what I wanted. We did it. Questions, comments?
So it really isn't an answer, it's just like showing the work.
So your answer is that you get the same thing as the right hand side.
Okay.
And so I am looking at all of your work. Did you do the right steps? Some of them, like these first two, have very few steps. The next few will start adding some more steps. So you'll kind of see what work I'm looking for. Number 3, it looks a lot more complicated, but I promise it's going to break down super easy very quickly. You have a couple options we can do. Again, look and see which side looks more complicated. I know sine x plus cosine squared x is not the simplest, but it's not as complicated as this over here. There's a lot of room for some simplifying on the left-hand side. So we're going to do that side. You can do one of two things. You can first either make everything in terms of sine or cosine, or we can distribute and then decide what's in terms of sine and cosine. And I actually think I want to distribute first. There's no right or wrong way. I just think distributing is going to make more sense to me in this problem. So I'm going to multiply cosine times tangent and multiply cosine times sine times cotangent. Know that a cosine doesn't go to sine and to cotangent. It just goes to like that one piece altogether. So I'm going to say, okay, cosine of x times tangent x, just they go next to each other. And then I'm going to do sine x, cotangent x, and then cosine x. Again, these two are not separate. They're all one, so cosine just goes with them. Now this looks kind of messy, but let's now put everything in terms of sine and cosine and see if we can start crossing out. So cosine times tangent, cosine stays the same. So we're just going to keep it as cosine over 1. And then tangent, we just did this a minute ago. So if you forgot, it equals sine over cosine. Okay, those are my first two. I did cosine, I did tangent. Now I'm going to do sine. Well, that's just going to be sine over 1. I cannot simplify that anymore. Now I'm going to do cotangent. Again, I told you that cotangent is 1 over tangent, but that's not a super helpful flip. It's not a super helpful substitution. What is more helpful is that cotangent equals cosine over sine. And then last, I've got cosine by itself. I'm just going to do times cosine over 1. Okay, any questions so far? Now that I have it here, I'm going to cross out what I have. I've got cosine and cosine cross out, so I'm left with just sine x over 1. And then I have on the other one, I've got sines get to cancel, and now I've got my two cosines together. The cosines are both on top, so they don't get to cancel out, but we can do cosine times cosine, and that becomes cosine squared. Now I can keep them over 1, but that's kind of redundant. So I'm just going to erase that. And I got sine x plus cosine squared x. When in doubt, you can always just keep checking back in. You're like, am I where I need to be? Do I need to keep going? Am I done? It looks like we're done here. Sine x plus cosine x, cosine squared x, sine x plus cosine squared x. Those are the same. So we did it. We're done. I'm looking for your distribution and your simplifying. And you can do those in whichever order, you'd still get the same answer. All right, the next two problems have some fractions involved, so those become a little bit more tricky. But the first three were pretty easy. Anybody have any questions on those first three? Again, I know I'm doing a lot of heavy lifting today, but it's so now you have examples when you go to look at the homework, or when I make you in class next time, do some of these on your own. So there's a lot of tips and tricks. I'm just talking through them because there's so many different ways to do this. There's not just one answer. There's like 5 to 10 strategies I use, and I want to kind of address as many of them as possible. All right, number 4, tan x plus secant x equals cosine x over 1 minus sine x. This is a weird one. I'm actually going to change to the left-hand side. I could go both ways, and actually in my notes, I showed both ways. So if later you want me to prove it the opposite way, I'd be happy to do so. However, I think that it's going to make a little bit more sense here. This is one of the first problems where I'm going to use a strategy that like I would not expect you to know on your own by yourself without me having taught this to you. But I'm showing it to you to see that it's an option, that we're going to use it in the future. Well, let's start on my left-hand side. I've got tan plus secant. Let's make those in terms of sine and cosine. When in doubt, if you're like, I have no other way to go, make it in terms of sine and cosine. The other one in doubt is use your Pythagorean identities, but nothing over here is squared, so I can't do anything with it. I'm going to make tan sine x over cosine x, and I'm going to make secant 1 over cosine x. Oh, that's actually really nice. I have 2 fractions and they both have the same denominator, so let's combine them into one fraction. That gives me sine x plus 1 over cosine x. Okay, cool. Okay. Now, normally I get here, and if I didn't have any previous experience, I'd probably be like, what else am I supposed to do? Like, how do I get it to where I want it to be? The hint I'm going to give you is, see that I want cosine x on top. We need to get a cosine on top. And the best way to do that is to just multiply on top and bottom to keep, the integrity of this fraction. I'm going to multiply by cos x on top and bottom. And again, the only reason I really know to do that is because I would need to end up with a cos on top. So let's get one up there and see what happens. I'm not going to distribute on top until I know that that's necessary. So I'm going to keep it as cos x times sine x plus 1. My hint is to keep it always in that factored form. Don't distribute until you absolutely have to, because it's going to be way more complicated if you have to factor it back again. If you just keep it in this form, it's sometimes easy to simplify in a few minutes. And it would be harder to have to refactor it and then recognize that I can simplify that. On the bottom, I get cos x or cos squared x. Okay, cool. What a lot of students want to do is they're like, oh, now I've got a cos on top and bottom, let's cancel it out. Well, then we'd be in this gross loop where we're just going back to the step we just did. I don't want to cancel x because I literally just multiplied by cosine x on top and bottom. So I don't want to get rid of my cosine because I just made that happen. I need this cosine on top, so let's not cross it out. I don't want to do that. Don't keep going in the endless loop of multiplying by cosine on top and bottom, canceling it out, multiplying, canceling it out. Now that I'm here, though, I want you to look at your identity sheet. There's an identity that says cosine squared of x equals something. Cosine squared of x, and if you go look at your identity sheet, it equals 1 minus sine squared x. I can replace cosine squared x with 1 minus sine squared x, and that's the same thing. Those are interchangeable. They're congruent. They're the same. They're equal. So I'm going to do that. The reason I'm going to do that is I'm going to be able to factor this 1 minus sine squared momentarily, and that's going to help me cancel on top. But we'll do that in a second. Let's first substitute this in. So I'm going to keep my numerator the same, but I'm going to put on the denominator 1 minus sine squared x. Again, this is literally a statement on your identity sheet. If it is not, you need to get your identity sheet fixed because this is a statement that we know and we're going to use. It's a tool, it's a puzzle piece. So I replace cosine squared x with 1 minus sine squared x, and I'm going to keep my numerator the same. I've got cosine of x times sine x plus 1. Now, the denominator, 1 minus sine squared, is actually a difference of squares. Again, I said this was algebra. If I wrote x squared minus 9, and you don't have to write this if you don't want to. If I wrote x squared minus 9, you could factor that, right? What times what? What times what? That would be x minus 3, x plus 3, right? X squared breaks down to x and x, and the 9 is the same thing as 3 squared, so it breaks down into a minus 3 and a plus 3. It's the same concept here. 1 is a perfect square, so I'm going to go 1 and 1. If I can pick the color I want. And then instead of writing 3 and 3, I've got sine squared, which I can break apart into minus sine and plus sine. Minus sine of x plus sine of x. So 1 minus sine squared x is comparable to x squared minus 9, so I could factor it in the same fashion. Now, if you struggle with that, I'd maybe come see me outside of class because that's a factoring from Algebra 1, Geometry, Algebra 2, and I can help you with that, but I don't have time to explain during class. I replaced it, though, and now I actually have something awesome. I've got a sine x plus 1 on top and a 1 plus sine x on the bottom. If you were to rearrange those or rewrite those, they're the same thing. So I'm going to cross them out, and I'm going to get cosine of x over 1 minus sine x. Ooh, and that's exactly what I want it to equal. That is the final answer, so I did it. I finished. Again, I could have gone the other side, but for sake of time, I'm just going to show you going from the left to the right. Anybody have any questions? Okay, we got 2 more I want to get to. Everyone buckle up. All right, number 5. Again, you can start on the left or the right. I'm going to argue that the left side, this tan squared, this secant x plus 1, is going to be easier to like move things around than the right side. So we're going to make the left side equal 1 minus cos over cos. The first thing I see is tan squared x. Anytime you see a squared trig function, sine squared, tan squared, cosecant squared, whatever, look to see if it's one of your Pythagorean identities and see if we can replace it. Again, it's only with the squares, but go look. I'm going to tell you right now while you're looking that I know that tan squared x is the same thing as secant squared x minus 1. That is on your unit circle. It is one of the identities I told you to write down the other day. The reason that's helpful is I'm going to replace tan squared with secant squared x minus 1. So I can rewrite tan squared as secant squared x minus 1, and then everything else is the same. I still have secant x minus or plus 1 on the bottom. I just replaced the numerator. Anybody have any concerns about that? Now, secant squared x minus 1 is just like the problem we just did. 1 is a perfect square, sine squared was perfect square. Secant squared is a perfect square, 1 is a perfect square. So I'm going to factor this using my difference of squares just like we did last step. However, secant goes first, so it's going to go first in my parentheses. I'm going to do secant x plus 1, and I'm going to do secant x minus 1. So again, this was just a difference of squares. However, once I do that, I know that this is going to be so helpful because I've got a secant x plus 1 on top and on bottom. So they cross out, which leaves me with just secant x minus 1. However, I'm not done. Close, but I'm not done. I need it to be 1 minus cosine over cosine. Let's make secant in terms of cosine and then kind of see what we need to do to keep manipulating it. Secant x minus 1 is going to be 1 over cosine minus 1. Okay, we're getting close. I don't want two fractions, I want one fraction. So the easiest way to get one fraction is to get like denominators. Okay, if there's cosine in the bottom of the first one, I need to multiply by cosine on top and bottom of 1 in order to get cosine in the denominator. That becomes 1 minus cosine x, or sorry, 1 over cosine x minus cosine x over cosine x. Now you might have skipped this step and gone right to writing them all together, and that's totally fine, but I didn't see that until now. So now I'm going to write 1 minus cos x over cos x. Like denominators means I can make it one fraction, and that's what I wanted. I did it. So again, all we've been doing is using our Pythagorean identities. We're substituting, we're factoring, we're substituting our secant x with 1 over cosine as our reciprocal identity. We're getting like denominators. Literally all of these steps are algebra. I'm just using sine, cosine, secant in order to confuse us up. I got one more problem, but does anyone have any questions before I do this one last problem? Okay. This last problem, anytime you see two fractions, deal with that side first. So I'm going to get this side to be the second side. So I'm going to get the left side to be the right side. You can do this one of two ways. You can just get like denominators by multiplying the second equation by 1 minus cosine, and the first one by sine. That would be able to get like denominators. I actually saw something else, but actually let's, for sake of the argument, let's do it that way. I made it a little harder for the last class, so maybe this will be a little bit easier for all of us. So I'm just going to multiply by sine on top and bottom for the first one to get sine in the top and bottom. And I'm going to multiply by 1 minus cosine on top and bottom for the second equation. That gives me sine squared t on top. And I'm going to keep the bottom simplified. I'm going to keep it sine t and then 1 minus cosine t. I'm going to make this 1 plus cosine t times 1 minus cosine t. Over sine times 1 minus cosine t. So all I did was multiply by the opposite denominator. That gives me, I'm going to combine everything together. I've got sine squared t plus 1 plus cosine t times 1 minus cosine t over sine 1 minus cosine t. Okay. Let's see, I cannot cancel anything out. I want to get rid of that cosine 1 minus cosine t on the bottom, but I can't do that yet because I've got sine squared on top. Let's see, what can I do? I can make, let's see if I distribute this, 1 minus cosine t. Let's distribute that through. It's going to be a perfect square because I've got 1 times 1 is 1. I've got negative cosine and positive cosine. So I've got minus cosine t squared over sine 1 minus cosine t. Now we can replace this as sine squared. That's one of your Pythagorean identities. 1 minus cosine squared t is the same thing as sine squared t. So I can make this sine squared t plus sine squared t on top over sine t 1 minus cos t. Your first inclination might be to cancel out your signs, but I'm going to argue not to. If I combine them, I'm going to get 2 sine squared t on top over sine t 1 minus cosine t. Now, a second ago, I told you to replace 1 minus cosine squared t with sine squared t. Now I want to go backwards because we got to get rid of this 1 minus cos t. So now I'm going to replace this sine squared t with 1 minus cosine squared t over sine t times 1 minus cosine t. I know it's almost done. Give me a second. And then the last thing I would do is unfactor 1 minus cosine squared to be 1 plus cos t, 1 minus cos t. And that's where we're able to just to cancel your 1 minus cos on top and bottom to get where we want it to equal. 2 times 1 plus cos t over sine t. Okay. Now I did that this way this class because I thought it would be easier, and it was way harder this way. So actually when I dismiss you guys, I'm going to stay on for a minute and do it the way I did it for F period. So if anyone wants to see this again or decided to leave early, I will finish this problem momentarily. However, that's us done with 5.2. Your test is tomorrow. I'm going to let you go, but if you have any questions, stick around. If not, I'll see you on Zoom tonight.
Thank you.
Bye. Thank you. Thank you.
Thank you.
Bye. Thanks.
What time is the Zoom tonight?
8 o'clock.
Okay. Thank you.
Thank you. I'm going back to my screen now that everybody's gone. So I'm sorry if you're still zooming with me, but I need to finish this problem correctly and then I'll go to A period. I'm just going to do it in a different color. So apologies, G period. The original step makes it look easier, but I'm going to argue that it's not. And that's why I'm doing it the same way I taught F period. The way I taught F period, I'm going to erase what's on top, is instead of just multiplying by the opposite denominators, I'm going to multiply in order to get sine squared x on the bottom. That's going to be super easy for the first one. Sine squared, or sine times sine, is going to be sine squared. So the second fraction, if I just multiply by sine on top and bottom, I'm going to get sine squared. However, for the first one, I need to remember that sine squared is the same thing as 1 minus cosine squared. And like we've just done the last few problems, 1 minus cosine squared is the same thing as 1 plus cosine, 1 minus cosine. I'm still using my difference of squares through the last 3 or 4 problems. And so instead of multiplying by the opposite denominator, if I multiply 1 plus cosine on top and bottom here, I'm going to get 1 minus cosine squared, which we also know as sine squared. So use this kind of math right here. I'm going to get sine times 1 plus cosine on top of the first one. And I'm going to get sine squared on the bottom of the first one. Again, use my work right here to remind yourself of that. I'm going to have sine times 1 plus cosine again on top on the second one, and sine squared on top on the second one. I'm going to combine them together and do, before I combine them, let's distribute that sign. Distribute. I get sine t plus sine t cos t. And then I'm doing the other one now, sine t plus sine t cos t. And all of that's over sine squared because we added our two fractions together. Now I'm going to combine my like terms. I've got sine and sine. So I've got two sine t. And then I've got sine t cos t and sine t cos t. So I've got two sine t cos t. And all of that's over sine squared. We're almost there. Do you see now how I've got two sine in each of these, two sine there and two sine there? We can factor out a two sine, and I'm left with 1 plus cosine over sine squared t. And then now if I cancel a sine on top and on bottom, I have 2 times 1 plus cos t over sine t, which is the same as up here. So the purple work is what I did with F period, and I think it's simpler than what I just did with you guys in G period. However, it's good that I showed you both ways. You can do it by multiplying by the opposite denominators, but it actually was easier to just get sine squared. If I could see that I could do it, let's get it that way because it made it a lot easier as we went along down. Okay, I gotta sign off because I gotta go to my next class. But I hope if anyone needs to watch this, I hope you find it helpful. Have a good day.